So mean is equal to 5 plus 6 plus 8 plus 4 plus 10 plus 3. All this divided by the number. And how many do we have? 1, 2, 3, 4, 5, 6. So all this divided by 6. And if we add all this up and divide by 6, what does that give? So this is 5 plus 6 gives 11. 11 plus 8 gives 19. 19 plus 4 gives 23. 23 plus 10 gives 33. 33 plus 3 gives 36. 36 divided by 6 will give us 6. So this is the mean. Now, in order for us to get summation x minus x bar squared, as I've said, it will be each value of x. Each value of x you're subtracting from x bar, and then you're squaring, then adding it all up. So each value of x, let's start with 5. 5 minus the value of x bar is what? 6 squared, plus the next one is 6 minus 6 squared, plus 8 minus 6 squared, plus the next one is 4 minus 6 squared, plus 10 minus 6. Remember, 6 is the mean. Finally, plus 3 minus 6 squared. This right here is what gives you summation of x minus x bar squared. So what is all this if we square and add? So this gives me 5 minus 6 is minus 1. Minus 1 squared is 1. Plus this gives me 0. Plus this gives me 2 squared, which is 4. Plus this gives me 4 minus 6, gives me minus 2. Minus 2 squared will give me positive 4. Plus 10 minus 6 will give me 4. 4 squared will give me 16. Plus 3 minus 6 gives me minus 3. Minus 3 squared will give me 9. So adding all this up, what do we have? Remember this is just the upper part, summation x minus x bar squared. So if we add all this up, what do we get? 1 plus 4, that's 5. 5 plus 4, that's 9. 9 plus 16, that's 25. 25 plus 9, that is 34. 34. So how are we going to go about getting the standard deviation? Look at the formula. It is the square root of summation of x minus x bar squared, and we've gotten the summation to be 34. All this divided by n, the number. How many are they? 1, 2, 3, 4, 5, 6. And if we evaluate this, 34 divided by 6 is the same as, if you get 34 divided by 6, it will be the same as 5.6. The square root of 5.6, if you evaluate that, you will get it to be 2.380. So that's how you go about getting the standard deviation of ungrouped data, guys. I'll give you more examples to try on your own. You can do this example. Can I close this page? Have you guys already written all this?
Yes.
Okay, fine. So we can have this example. You can do this example at your own free time. Find the standard deviation of the data set is 35, 22, 25, 23, 28, 33, 30. If you evaluate it correctly, the answer should be 4.60. So do that and see if you're getting 4.60 as your answer. Okay, guys, so the next thing I want us to look at is mean, median, and mode of grouped data. Mean, median, and mode of grouped data. So if you're given some grouped data, how do you go about getting the mean, median, and the mode? Okay, so allow me to close this page. So we look at mean, median, and mode of grouped data. Now, first of all, let's start by getting mean. If you're given a particular set of grouped data, then the mean, which sometimes is also represented as x bar or mu in some text, is given by summation Fx. Let me write it this way. Summation Fx over summation F. Summation basically entails you adding all the values of the Fx. Now, remember, this is grouped data. So x at this particular point will be representing the midpoint. So let's see how exactly this is summation. Let's see how exactly we go about that. So let's take some data which is grouped, and let's see how exactly we get the mean. So let's say you have data sets. You have values 1 to 5. Then you have 6 to 10. Then you have 11 to 15. Let's just have that. Then you have, this is 2, 1, and this is 2 as well. So this is data. This is your frequency. So in order for you to get the mean, you obviously require the value of your x. Now this data is grouped. So in order for you to get x, x entails you getting the midpoint. Now, how do you get the midpoint of a particular data? I'll write it here. Midpoint of the data is given by lower limit plus upper limit divided by 2. Now, what's the lower limit? What's the upper limit? For this particular data set, in each group, if you look at this group, this here, this value here, if you want to know what the lower limit is, now you look at, first of all, the distance between this point and this point from one set to another. What is the distance? It is 1. Now 1 divided by 2 gives you 0.5, such that if you want to get the lower limit of this particular point, it is 1 minus 0.5. And if you want to get the upper limit of this point, it is 5 plus 0.5. So note, guys, for lower limit, you subtract the 0.5 from that lower point there. And for upper limit, you add the 0.5 from this upper point here. So when we want to get the midpoint of a particular set, as I've said, it's lower limit plus upper limit. So what's going to be the midpoint of this particular point here? It will be 0.5 plus, this is 5.5, all this divided by 2. All this divided by 2. And what does that give? 0.5 and 5.5 will give what? 6. 6 divided by 2 will give 3. That is our midpoint. On this set here, what is going to be our lower limit? Our lower limit will be 6 minus 0.5. So it will be 5.5 plus, what is our upper limit? 10 plus 0.5. So 10.5, all this divided by 2. So what will be our midpoint? 10.5 plus 5.5 will give what? 16. So our midpoint will be 8. On this point here, what's our lower limit here? 10.5 plus, on this point here, we have 15.5, all this divided by 2. So what does this give? If you add 15.5, 10.5, what do you get? You get 26. 26 divided by 2, you get 13. So we have our values of x. So what is summation Fx? Let's extend the table. In order for us to get summation Fx, so Let me just draw that so that you know that's up. In order for us to get summation fx, we need to first of all find fx. Fx basically means f times x. And then summation fx we will find here. It will be all the values of fx added. By the way, summation f is adding all the values of the frequency. So what is summation f first of all? Summation f is 2 plus 1 plus 2, which is 5. Summation basically means adding all the values. So let's come here and get fx. Excuse. So fx, f times x, that will give me what? 6. F times x, that will give me what? 8. F times x, that will give me what? 26. So adding all these values of f of x gives me summation f of x. So adding 26 plus 8 plus 6, what will that give me? So that will give me 40, yeah? So what is our mean? As I've said, mean is given by summation fx over summation f. And in our case here, it will be 40, all this divided by 5. And what is our mean? Our mean is equal to 8. The 0.5, so someone is asking where we got the 0.5 here. Now, in order for you to know where we're getting the 0.5, look at this range here. Now, this set here represents from 1 to 5, and this from 6 to 10, and this from 10 to 11. Now, I am looking at from here to here. What is in between here? It is 1. From here to here, what is in the middle here? Like from 10 to 11, it is 1. So in order for you to know what you're adding or subtracting from this lower limit or this upper point, you're taking this difference, 5, 6, the difference you're dividing by 2. So I took 1 divided by 2. That is what gave me 0.5. You look at this last point in your data, the first step, and you look at the first one. What is the difference? The difference is 1. You take that, you divide by 2. In order for you to get your lower limit and your upper limit, you will add or subtract that 0.5. The 0.5, you get it from looking at this and this. The difference between 5 and 6 is 1. 10 and 11 is 1. Moving from one group to another, there's a difference of 1. So that 1 is what you take and divide by 2 in order for you to get to know what you're subtracting or adding to get your lower or upper limit. I hope that is clear, Mpule. Okay, guys, so that's it. You get your mean as 8. Now, I want you guys to take up an example. I'm sure we're going to be cut short by time, but you can do this example and then you tell me the answer when we come back for the last session. So I hope you guys have already written this.
Yeah.
Okay, sawa. So let's all evaluate the mean for this particular grouped data. Get the mean of so this is the data 20.5 to 20.9, 21.5 to 21.9, 22.5 to 22.9, 21. Okay, guys, I'll have to rewrite this again because this is 20.9. Then I'll have to write the data again. There are some that I've left out. So that's 20.5 to 20.9. Then I have 21.0 to 21.4. Then I have 21.5 to 21.9. Then I have 22.0 to 22.4. Then I have 22.5 to 23, sorry, 22.5 to 22.9 to 22.9. Then I have 23.0 to 23.4. Then the frequencies are, so this is the data, this is the frequency. So
is that 22.9?
Which one? This one? This one?
Yes.
Yes, that is 22.9. Okay, so the frequencies, we have 3. This is 10. This is 11. This is 13. This is 9. And this is 2. So guys, let's determine the mean. We have like 2 minutes left. So I'm expecting you guys to give me the answer when we resume. Determine the mean. Note, in order for you to be able to know the lower class limits so that you can be able to get the midpoints, look at the difference between this and this. And what is the difference? Let me just show you that first. 21.0, 20.9. What does that give? What does that give, guys? What's the difference? 0.1, okay? So in order for you to know what you're going to subtract here and add on this point, itakuwa 0.9, all this divided by 2. And what does this give? 0.05. So let's say like for the first point here, what's the lower limit here? The lower limit will be 20.5 minus 0.05. And the upper limit will be, so that will be the lower limit, and the upper limit will be 20.9 plus 0.05. So this is what I will be adding to this, dividing by 2 to get the midpoint. I hope that's clear, guys. So do that, and then you come back, you give me the answer. Okay, 1 minute for this session to end. So you'll have like 10 minutes to do that work because the next session starts at 7:40.